I want you to go into your book and fill in all of these vocabulary words about a matrix. What does it mean to be, if they're equal, dimensions, adding them, scalar. Again, all this stuff is stuff that you should know from last year. But again, the properties, zero matrix. One thing I want to jump to is this matrix multiplication. If a matrix is being multiplied to another one, and you have an M by N, row by column matrix, and B is an N by P matrix, when you multiply A and B, you get an M by P. Because what's important with multiplication is that the columns of the first has to match the rows of the second. The resultant is those outside numbers, the rows of the first, columns of the second. Whenever we do a multiplication of matrices, it's a row by column multiplication. We take the row of the first times the column of the second. So here I have a 3 by 2. Here I have a 2 by 2. So when I'm finished, because those match, my ending will be a 3 by 2. In order to find that 3 by 2, I'm going to take the row times the column. So I'm going to take the first location, -1, times the first location, -3, and I'm going to add it to the second, 3, and the -4. Row by column. First row, first column is the first row, first column of my solution. Okay? Then I'm going to take first row, second column. So first row, multiply the corresponding pieces, add, multiply. First row, second column is the first row, second column of my solution. Keep in mind, we're looking for, because of the dimensions, we're looking for a 3 row, 2 columns. Okay? So here we're going to go next, second row, first column, 4, -3. Add 4, -4. Oh, wait. 4, -3, -2, -4. Second row, first column. So that's the second row, first column. Then we have second row, second column. Multiply, add, multiply. Second row, second column, second row, second column. Third row, first column, first row, or third row, first column, and then we have third row, second column. Multiply, add, multiply. So here's my 3 by 2, 3 rows, 2 columns. The solution is 3 minus 12, or -9. -12 and +8 for -4. -8 and 0. -2 and 3. 8 and -2. 10 and 0. 3 by 2. But you have to multiply, add, multiply. Multiply, add, multiply. And it goes across and down, across and down, across and down. right, in our calculators, we can do these by going into the matrix form. So second matrix. We need to edit. We're going to call the first one matrix A, and it is a 3 by 2. So 3, enter, 2, enter. And then type in the numbers that are on the page here. -1, 3, 4, -2, 5, and 0. Same thing, we need to go edit, but now put the second one in matrix B. And it's a 2 by 2. And the numbers are -3, 2, -4, and 1. All right. We can then go to our home screen and bring back matrix A just by second matrix and then enter. And we can multiply that to matrix B. So back to our matrix screen and bring in B. A times B. Hit enter. Hopefully that's the numbers we came up by hand, which it's not. Oh, because 5 times -3 would be -15, not -8. And I'm sure those of you doing it at home was probably already questioning me. And there we go. You will be allowed to use your calculator, but you definitely have to understand how it works by hand. Okay, so on page 3, go into the book, find those properties, and put those in, talking about what it means to be an identity. Fill that in. On this fourth page, when it comes to a scalar, it just means to distribute. So distribute it to every single piece, take the negative of it, scalar it, and then subtract, remembering that in order to add subtract they have to be the exact same dimensions. So what I'd like you to do is complete that part of the examples. When you're solving for a matrix, in this case it's extremely straightforward. I just solved for this x. So I get 4x is equal to b minus a. Again, you can only subtract if they're the exact same dimensions. All right, and then you would divide by 4. So after I subtract them, I'm going to get a matrix of b minus a, and I'm going to divide by 4, which is nothing more than a scalar of 1/4. Divide every piece by 4. So finish that example. Multiply your two matrices. What I'd like to do, I want you to do it by hand. So go ahead and make your multiply, add, multiply, add, multiply, and then I want you to check it with your calculator. So I want to see both versions, the by hand and then your answer that you can verify with the calculator. All right, matrix multiplication can also be used to do a linear. This one, we can set up our coefficients, because we already learned that in the last section, then our variables, then our solutions. Okay, we can call this coefficient, we can call that A, and I can call the solutions B. So if I were to do this by our calculator, in order to solve with matrices, I can't divide by matrices, we do inverses. So I would have x, y, z is equal to inverse matrix A of B. Because in theory, I would divide by the A matrix, right? That's how I would get the letters by itself, is get rid of the A. But matrices, you can't divide by a matrix. I can divide by a number, but not a matrix. And so much like our tangents and trig functions, we do inverses, same idea. I do the inverse of A, and I put it with B. The inverse always goes first, if I were to do this with my calculator. Now, we don't have to do it with our calculator. We are very capable of doing it by hand, hopefully by now, because we know how to do the row echelon and Jordan-Gaussian methods. So what I can do is I can start doing my rules. I could, for example, I could take -2 times row 1 and add it to row 3. All right, that means row 1 is going to stay put, row 2 is going to stay put. And I'm gonna give you the rules, and I want you to do it by hand. Then do -7 times row 2, add it to row 3. Then I want you to do row 3 divided by -18. The next rule I want you to do is 2 times row 2 and add it to row 1. -5 times row 3 plus row 1. -2 times row 3 plus row 2. And then I want you to tell me what is x, y, and z. Okay, so if we have calculator available to us, good. If we have to do it by hand, we need to follow rules. Now you have to obviously create your own rules, but I've given them to guide you through this example. So I want you to finish that up on your own and come to class with that as well. And that is 8.2.